This is our ping pong ball launcher proposal presentation. I'm Victoria Bruce.
I'm Owen Conway.
I'm John Covert.
I'm Jacob Miska.
And I'm Eric Grant. So before we could even begin creating the product, we needed to define the target market we were looking for. And that was basically any players ranging from beginners to advanced that were trying to improve their skills. And then from there, we were able to define the customer needs, and we categorized that into primary and secondary. Our primary needs were that the ball needed to be launched at different speeds, different angles, and different frequencies, along with a pretty decently sized ball capacity. And then from there, we were able to define the secondary needs, which were that the product needs to be cost effective, needs to have a friendly user interface for the players to adjust the settings, needs to be easily set up, and needs to be compatible with all ping pong tables. And these are our stakeholder needs that we put into a table. We categorized them by performance and convenience, and then we listed the priority that the need hit.
So we actually next went into more further analyzing specifically what target specifications we needed. And as this is a product that we want both beginners and advanced players to be able to use, we want, first of all, for the adjustable ball speed to be between 5 miles an hour and about 25 miles an hour. Secondly, we want our ball frequency to be adjustable as well, from about 15 balls per minute to about 60 balls per minute, or about 1 ball every 4 seconds to 1 ball every second. And then we also want our head angle to be adjustable as well, both vertically and horizontally. We want a 90-degree range of motion vertically, so about from negative 45 degrees to positive 45 degrees, as well as having about a 15-degree horizontal range of motion for the ball to be launched at. We want our hopper, or our ball container, to hold about 40 to 60 balls, so that the player can hit a decent amount of balls before they have to stop and reload them cheap. Additionally, we want the cost to be about $80 or less, so that way it's cheap for us to produce, as well as cheap for the consumer to buy, so that way they actually consider our option. And lastly, we want the time to assemble and disassemble this machine to be about 10 to 20 minutes. This is our target specifications table. It basically just takes all of the target specifications we had on the last slide and organizes them nice and neatly. So this is our concept combination table. So this basically just defines what every concept needs to accomplish in order to work properly. So every concept must take some electrical energy and convert that to translational energy using motors, servos, and solenoids. And then that rotational translational energy is shown through the driving wheel, and the driving wheel actually powers or used to spin and accelerate the ping pong ball, which is then launched out from the ball launcher with that energy.
So this was our first design concept. You can see that the ball container is large enough to fit multiple balls in blue. You have a motor driving wheel right here in black, and when the ball is released, it goes down the adjustable ramp that you're able to adjust the left and right position and the height of it by this yellow swivel down there, which contains the Arduino. Our second design concept also has a large ball container. It has 2 driving wheels this time in order to more accurately adjust the speed. The launching tube is not adjustable in height, however the Arduino is equipped with wheels down here in order to adjust manually the left or right position, or move closer for a higher aim, or backwards for a lower aim. And our third design concept, you can see the ball storage in green up here. You can see the yellow driving wheel, the blue launching tube. And what we did in this one is, instead of making the Arduino move, we have 2 wheels down here that can adjust the height or the left and right position of the launching tube in order to adjust the aim.
This is the design matrix we used to compare all 3 of the proposed designs. Highlighted in yellow is design concept 1. This was determined to be the most viable design concept. The design easily fulfills all the necessary requirements, such as ball capacity, adjustable speed, frequency, and angle. Additionally, the design minimizes the amount of moving and complex parts, which makes it both simple for construction as well as easy for the user to set up. Finally, the price of the design was determined to be the lowest. All the parts could be easily manufactured using 3D printing or other means. These are the equations we're using to determine that the product will work correctly. For the mechanical systems, the kinematic equation shown here and the drag force equation will be used to ensure that the ball leaves the system at the proper angle and with enough speed. For the electrical systems, Ohm's law and the power equation will be used to ensure that the system is properly powered.
So based off of the design matrix, we decided that this was the design that we should be moving forward with. As you can see, there are different dimensions shown between the three screenshots here. We've got the first one all the way on the left. The top of the ball container is approximately 1 foot in diameter. That way we can hold a large amount of ping pong balls at once. Then it funnels down to a 2.5-inch diameter hole, so only one ping pong ball at a time will get through, and there will be a servo motor controlling the amount of balls that get through every minute. Then the ping pong balls go down to the black wheel here, and you can see down at the bottom we have our 16-inch diameter dimension. This is the widest point on the system. This is so it's a very stable base, and that when things are moving or spinning based off of the motors and the launching system, that it's stable. So this is our concept evaluation. So this full system is broken down into 4 subsystems. The first is the feeding subsystem, which comprised of the ball container and the feeding servo, so how fast and how many balls are fed through to the launcher at a time. Then it goes on to the launching subsystem, which is the launching wheel and the solenoid at the lip, which changes the vertical height of the ball launch. Then there's the aiming subsystem, which is comprised of the base and the swivel motor, so the horizontal aiming. And then there's the control subsystem, which is comprised mainly of the Arduino and any other electronic components. And then the final slide is our Gantt chart. So this is the timing for our project, starting with forming the team and creating our preliminary report earlier this year, and then it moves on to our technical analysis, our proposal presentation, which is this, and then moving on through our detailed design, building, testing, and down to our final presentation at the end of the semester.
Any questions?
In the back? Oh, you're just touching? Okay.